Okay, so for honors chem, this is how to solve different types of gas law problems. All right, there's basically 4 types, or I don't know, 3.5, because 2 of them are pretty similar. First one is going back to using Dalton's law of partial pressure, as well as using our universal gas law. Okay, so in this particular problem, hydrogen gas is collected in water. So anytime anything is collected in water, there's going to be a vapor pressure of that water. Okay, and it's relatively low. It's 17.54 torr. 20 degrees, and the total atmospheric pressure is 1. 50 mils were collected. We need to find the number of moles of hydrogen gas collected. Okay, so essentially what we've got hydrogen gas being generated. So we're going to run a tube over. Notice we have a graduated cylinder, and it has water in it. And what's going to happen is all these bubbles are going to, hydrogen is going to bubble up and eventually fill in the container. So what's inside this container is going to be mostly hydrogen, but there's also going to be some water vapor as well. Okay, so we have water, and we also have hydrogen gas that's being collected. Okay, so what we need to do essentially is we need to subtract out the water vapor in there. Okay, so we're going to use Dalton's law to do that. Okay, so total pressure equals the sum of the partial pressure. So that's going to be the partial pressure of the hydrogen gas and the partial pressure of the water vapor that's in there. And we're given the total pressure is 1 atm, and we'll just do a quick conversion. That's 760 torr. We're given the water vapor pressure is 17.54. So just subtract 17.54 from both sides. That gives us hydrogen's vapor pressure of 742.46 torr. Okay, so now we're just going to use Pivnert, and we're going to use everything for hydrogen. So hydrogen's vapor pressure, hydrogen's volume. We're going to use the temperature of hydrogen. It was 20 degrees Celsius, so 273. Remember Highway 273 plus 20 degrees is where we get our 293. And this is our R value. Look it up on your R chart. And you got to look up torr, which is the same as millimeters of mercury, and milliliters, and that'll give you 62,400. And you need to isolate N, so divide both sides by 62,400, and also divide both sides by 293. Okay, and that will give us 2.03 times 10 to the negative third moles. Okay, next type of problem will be trying to find the molar mass of an unknown compound, of an unknown gas, and which obviously would be useful in determining the chemical formula of it. So let's get started. First of all, molar mass, remember, is grams per mole. So let's say if we have sodium, sodium weighs 23 grams per mole, and that's just 1 mole. Okay? If we had 2 moles of sodium, those 2 moles would weigh twice that, right? 46 grams. Okay, so the molar mass is always going to be 23 grams per mole for sodium. All right, next one we're very familiar with, Pivnert. Okay, so essentially what we're going to do is combine Pivnert with the molar mass formula. So if you notice, what do these two formulas have in common? Well, moles. Okay, so what we can do is we can isolate our molar mass formula for moles and then substitute that in for the moles in Pivnert. So the first step right here, molar mass equals this one, grams over moles, is if we multiply moles by both sides, those will cancel out, and then divide each side by molar mass. So that gives us this right here. Moles equals grams divided by molar mass. Now we can take grams divided by molar mass and plug it in 4 moles, which will give us now PV equals, instead of N, we substitute grams over molar mass times RT. And then the last one is to get moles by itself. Molar mass by itself. So we're going to multiply both sides by molar mass, and then we're going to divide both sides by PV. Okay, which gives us this equation right here. Okay, so notice PV is on the bottom, and if you look at this right here, mass per unit volume, that's density. So we can look at it this way: molar mass equals density RT divided by P. And that's the formula we're going to use in the next problem. Okay, so here's our problem 2A. We're going to try and find the molar mass of a diatomic gas. So, and the reason we're trying to find the molar mass is so we can try and identify what type of gas it is. And it says we have 50 grams of it, and we're given a volume, we're given temperature and pressure, and then so once we find the molar mass and get a numeric value, then we need to figure out what is the actual formula, because we know it's a diatomic element. Okay, so we're going to use our formula that we just isolated, and we're going to substitute the 50 grams in here. We're going to look up R on our chart. Temperature, remember SDP is 0 degrees Celsius and 1 atm. Okay, 0 degrees Celsius is 273 Kelvin. So that's going to go in for temperature. And then we're given volume, and pressure is 1 atm. Whoops. Right there. Okay, so substituting all that in, multiply the tops, divide by the bottoms. Because of our units for R, I didn't write them. They should be right here. But everything will cancel out except for grams and moles, which are with the units of the R. So anyways, that gives us 38 grams per mole as its molar mass. We know it's diatomic. So what element has a mass of that when it exists in pairs? And that would be fluorine, because molar mass of 1 fluorine is 19, so double that and you get 38. Okay, next type of problem is just a slight variation of the first one. This time we're given density, and remember, density is mass over volume. Okay, we're given temperature, pressure. We want to find the molar mass. So here's our formula, and remember, we can just substitute density in for that. So we'll plug in our density here. We'll look up our R value on our chart. Temperature, remember we need to add 273 to the 25, which will give us 298. And we need to enter the pressure in there. 380 torr is the same as 380 millimeters of mercury. So once we do that again, we have all of our units for R. Everything will cancel out except for grams per mole. So dimethyl ether has a molar mass of 46 grams per mole. Okay, so third type of problem is combining the gas law and stoichiometry. We're actually going to do these types of problems in day 2. Okay, so here's our problem. So zinc reacts with hydrogen chloride, which is hydrochloric acid. So here's our equation: zinc, HCl, and that is a single displacement reaction. So zinc has a 2+, chlorine has a 1- drop-in swap. That gives us ZnCl2, hydrogen diatomic plus H2. Okay, if we put a 2 in front, everything's balanced. And here's what we're doing. This is, we have 10 liters of hydrogen gas is collected at 20 degrees Celsius, 1 atm. How many grams of HCl were used? Okay, so if we look at our mole floppy that I put up here, okay, so here's our mole floppy, grams to moles to volume. Okay, anytime you go from moles to volume or volumes to moles, you need to use Pivnert. Okay, so same thing here, Pivnert. All right, so here's what we're going to be doing in this problem. we're first of all starting out, we're given 10 liters of hydrogen. Okay, so we're starting here. Okay, and it says we're trying to find grams of HCl used. So we're trying to get to there. Okay, so first step is our first step. Oops. It's going to be using Pivnert to find moles of our hydrogen. And then we're going to go from moles of hydrogen to moles of HCl. And then finally our third step is going to be from moles of HCl and just convert it into grams. So that's kind of outlining what we're going to do. All right, first step, we're going to use Pivnert. Okay, we're given 1 ATM, 10 liters. We can look up R, and we're also given 20 degrees Celsius, which is 293 Kelvin. Okay, we're going to solve for N. So divide both sides by 0.0821 and 293. Okay, and that will give us 0.4 moles of H2. So we just went from volume of H2 to moles of H2. Okay, so next step is to go from moles of hydrogen to moles of HCl. Okay, and that we need a mole ratio to do that. And if we look in our equation, we have 2 moles of HCl for every, it's implied, 1 mole of hydrogen gas. Okay, so let's go ahead and start with the 0.42 moles of hydrogen that we calculated. 1 mole of hydrogen per 2 moles of HCl. Moles of hydrogen cancel out. And the very last step is moles to grams. And we need to look up the molar mass of HCl on our periodic table. 1 hydrogen, 1 chlorine gives us 36.45. So moles of HCl will cancel out, and we'll be left with grams of HCl. And that gives us 30.62 grams of HCl. So what you really want to do is you really want to use this mole floppy table here. Okay, use it every single time. It won't take you very long, but map out where am I starting. In this case, we started with volume of one compound, and we're trying to get to grams of another. That'll save your bacon when you're doing these problems. All right, good luck.